Imagine a world where everything is reversed. Up is down, left is right. This is not a fantasy, but the intriguing realm of antimatter. Antimatter is a strange cousin of the matter we know. It holds the secrets to some of the biggest mysteries in the universe. Scientists have been captivated by antimatter for decades. They are working to unravel its secrets and harness its power. The idea of antimatter might sound like something from Star Trek, but it is a real phenomenon. It exists in the depths of space and can even be created in laboratories. Antimatter has the potential to revolutionize our world. It could provide us with new sources of energy and help us to understand the fundamental nature of reality itself. Join us as we explore the fascinating world of antimatter. To understand antimatter, we must first understand matter. Matter is all around us. It makes up our bodies, the air we breathe, and the stars in the sky. Matter is made up of tiny particles called atoms. Atoms themselves are made up of even smaller particles called protons, neutrons, and electrons. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. Antimatter is like a mirror image of matter. For every particle of matter, there is a corresponding antiparticle. Antiparticles have the same mass as their matter counterparts, but the opposite charge. For example, the antiparticle of the electron is the positron. It has the same mass as an electron, but a positive charge. When matter and antimatter meet, they annihilate each other. This annihilation releases a tremendous amount of energy. When matter and antimatter collide, they don't just disappear. They're converted into pure energy. This process is called annihilation. It is one of the most efficient energy releases known to science. During annihilation, the mass of the matter and antimatter particles is completely converted into energy. This energy is released in the form of gamma rays, which are a type of high-energy light. The amount of energy released during annihilation is staggering. It is governed by Einstein's famous equation, Keil-mc2. This equation tells us that a small amount of mass can be converted into a huge amount of energy. Just 1 gram of antimatter could produce an explosion equivalent to a nuclear bomb. This makes antimatter a very powerful substance, but it also makes it very dangerous. Section 4. Unveiling antimatter's secrets. Scientists have been studying antimatter for decades. They aim to understand how it is created, behaves, and can be used. Antimatter forms in high-energy events like cosmic ray collisions. Cosmic rays are high-energy particles traveling near light speed. When they collide with atoms in the atmosphere, antimatter is created. Particle accelerators also create antimatter in labs. These machines accelerate particles to high speeds. Collisions can produce antimatter. Storing antimatter is challenging due to annihilation with matter. Special magnetic traps suspend antimatter to prevent contact with matter. Section 5. Antimatter in our world. Antimatter may seem like science fiction, but it has practical applications today. One well-known use is in positron emission tomography, or PET scans. PET scans use positrons to create images of the body. A radioactive tracer is injected, emitting positrons that annihilate with electrons. This produces gamma rays detected by a scanner. Antimatter could also be a powerful fuel source. Annihilation releases immense energy, potentially powering spacecraft or generating electricity. Significant challenges remain, like producing and storing antimatter efficiently. Section 6. The future of antimatter. Antimatter is one of the most fascinating and mysterious substances in the universe. It has the potential to revolutionize our world, but it also poses significant challenges. Scientists continue to study antimatter in order to unlock its secrets and harness its power. The study of antimatter has already led to groundbreaking discoveries in physics. For example, it has helped us to understand the nature of fundamental forces and the early universe. As scientists continue to explore the universe, they are finding more and more evidence of antimatter. This suggests that antimatter may play an even greater role in the universe than we currently understand. The study of antimatter is a journey into the unknown. It is a testament to the power of human curiosity and our desire to understand the universe and our place in it.